When a program runs, how does it get the memory? Does the system gives all the memory at once, or does it give memory when the program asks for it? The answer is both, and that's exactly what static and dynamic memory allocations are. Memory allocation simply means giving memory to a program. Static memory is allocated before execution, and dynamic memory is allocated during execution. So the difference is very clear, before versus during. Now, if we talk about static memory, it is fixed and decided before the program starts running. The code segment we can see in the screen, the system already knows how much memory is needed. For the first variable a, we know the value 10 is there. The array we have defined is having fixed value of size, 5 size, right? So this memory is allocated in advance. And where does it allocated? Usually in the stack or data segment. Now comes the dynamic memory. It is slightly different. The program asks for memory while it is running. The code we can see in the screen. In C, we use malloc to provide a memory, right? So like this, if we run this program, then it will ask for the memory in runtime. And here the memory is not fixed earlier. The program requests memory from the heap. And this memory is flexible also. We can resize it. But the code segment that we have discussed earlier for the array which has defined size, we cannot increase that. So let's compare both with the code. Here if we see the code, we have defined array of 5 size and the values are there, and this static allocation is into the stack, and then there is dynamic memory allocation. Here we have used malloc for the memory allocation, and in this code, if we see the first array, static array, is created immediately, and the second array, dynamic array, is created only when the malloc runs. So static means fixed size and dynamic means flexible size. So we have a flexibility here to increase this size, increase the array of this size. So if we run this program, okay, yeah, so if you see the address we have printed for both stack, the memory allocated in the stack, and the memory allocated in the heap. So if we compare both, so it is something like, okay, let me edit this, 5, yeah, and 7. So the memory address, so this address is in the higher region, and this address in the lower region. As the stack grows downwards and heap grows up, so we can see the difference from the address values also. Yeah, so yeah, okay. Now if we talk about the static memory allocation, so that is fixed size, it is fast, and the automatic memory handling is there. But if we discuss about dynamic, then it has a flexible size, it is slower, but the memory, it should be managed manually. So like in the code also we've seen here, I have deleted this memory and we have to clean up, and this is necessary part. And if you see, we are not doing anything for the static array, but we have to do for dynamic array. So this is and also a difference. And with dynamic memory, as you all know, you must free it. And what if you don't free the dynamic memory? Let's say you forgot. We are human, we can make mistakes, right? So it will stay occupied. The memory we have allocated, if we don't free, it will stay occupied, and this can lead to a memory leak. And in long running programs, like the programs which are running, which are going to run for the long time, and they are going to use this memory again and again, and so this can crash the system also. So there is a risk. So dynamic memory is powerful but also dangerous. All the bugs like heap overflow, memory leaks, use after free, these vulnerabilities exist because memory is not handled properly. Like you saw in the program also, for static memory allocation we don't have to do anything, but for dynamic memory allocation we have to free it explicitly. So today we learn static memory is equal to fixed and automatic, whereas dynamic memory is flexible but manual. In the next video we'll understand executable files and how programs are structured on the disk. And remember, we will keep it simple.